Previous lesson, we took a look at writing the radical notation for an nth root. Well, today we're going to take a look at multiplying radicals. So this is called the root of a product theorem. Now, if we're going to write it in power form, then we have a product x times y to the 1/nth power. Remember, that power needs to go to both of those factors. So that's x to the 1/nth times y to the 1/nth. If we're going to write it in radical form, then we'd say the nth root of x times y is the nth root of x times the nth root of y. So let's get a little look at a few examples here and see how this works. We're going to take the square root of 108. However, it's not a perfect square, but we can separate it into its two factors, the square root of 36 times 3. Now, we can rewrite this as the square root of 36 times the square root of 3, which simplifies to 6 root 3. All right, in our next example, we'll do the same thing. The cube root of 16. Well, the cube root of 16 is not a perfect cube, but we can separate it into the cube root of 8 times 2. Now, I got to make sure that cube root goes all the way across. So again, if we separate that, that's the cube root of 8 times the cube root of 2, which is 2 times the cube root of 2. So the cube root of 16 simplifies down to 2 cube root 2. All right, our next example, we have the square root of 245. Well, again, it's not a perfect square. However, we can take the square root of 49 times 5. If we separate those two factors, we have the square root of 49 times the square root of 5, and that's going to come out to equal 7 root 5. All right, next one here, we have the fourth root of 1600. So we're going to take the fourth root of 16 times 100. Now the fourth root of 16 is 2, and the fourth root of 100 is just the fourth root of 100. So that's using the root of a product theorem a little bit to simplify radicals. Let's see how else we can use this. Our next example says to perform the multiplication. So here we already have it separated. We're going to actually bring it together now. So we're going to take the fifth root of 8 times 4, which is 32, and then we'll have x squared times x to the 8th. Now, when we multiply x squared times x to the 8th, remember we need to add our exponents. So this is really equal to the fifth root of 32 times x to the 10th. Now we can separate those back out. We have the fifth root of 32 times the fifth root of x to the 10th. Well, the fifth root of 32 is 2, and x to the 10th, the fifth root of that, can be rewritten as x to the 10 over 5, and we know that that simplifies to 2x squared. All right, example B, we're going to do the same thing here. We have the fourth root of 24 times y to the 6th times the fourth root of 54 y to the 10th. So we're going to bring these guys back together, and we're going to say 25 times 54, and then it's going to be y to the 6th times y to the 10th, which is y to the 16th. Now, when we multiply 24 times 54, we're going to have the fourth root of 1,296, and then y to the 16th. So again, we can separate these guys back out. This is the fourth root of 1296 times the fourth root of y to the 16th. Well, the fourth root of 1296 simplifies to 6, and this is y to the 16 over 4, which actually simplifies to just y to the 4th. So we have 6 y to the 4th is our final simplification there. All right, you can see how this can get a little bit complicated here. So just try to keep your power tables handy and in front of you. So, for example, let's simplify the cube root of 125, a to the 12th, b to the 27th. So I'm going to rewrite this. The cube root of 125 is 5. A to the 12th to the third power can be rewritten as a to the 12 thirds power, and then b to the 27 over 3. So this all simplifies to 5, a to the 4th, b to the 9th. All right, in example 4, we're going to rewrite the smaller powers of the variables inside the radical. Okay, now, up until this point, we've had everything divide really nicely. Like in example 3, we had 12 divided by 3, 27 divided by 3. Those were both even division problems. Here, we're going to take the fifth root of 32 times 3, which are the factors of 96, and we're going to multiply that by the fifth root of x to the 10th times the fifth root of x to the first power. Now what we did there is we separated x to the 11th into two powers, one that's divisible by 5 and the other one is the remainder. So let's separate this now. We have the fifth root of 32 times the fifth root of 3 times the fifth root of x to the 10th times the fifth root of just x. Now there's a couple of these that we can actually perform. The fifth root of 32 is 2, and the fifth root of x to the 10th is x squared. However, the other two, the fifth root of 3 and the fifth root of x, we cannot simplify any further. So what we have to do is put them back together under the radical, and that's the fifth root of 3x. So our final answer there is 2x squared times the fifth root of 3x. All right, let's try another example here. Now we're dealing with the fourth root, so we're going to take the fourth root of 10,000 times the fourth root of 5, and we're going to multiply that by the fourth root of x to the fourth power, and then multiply that by the fourth root of x to the third power. So again, what you can see here is we took 50,000, we broke it up into its two factors, one that is a perfect fourth root and one that is not. And then we took x to the 7th and broke it up into two factors as well, one that is a perfect fourth root and the other one that is not. So our final simplification here, the fourth root of 10,000 is 10. The fourth root of x to the fourth is simply x. However, the fourth root of 5 and the fourth root of x cubed need to stay under that fourth root, and we can put them back together to say the fourth root of 5x cubed. So our final solution here, our final simplification, is 10x times the fourth root of 5x to the third. All right, let's get a few more practice examples here of simplifying these radicals. In our next one, we have the cube root of 8, which we're going to simplify right away to be 2, times the cube root of z to the 11th. So we're going to break that down to z to the 9th, because 9 is divisible by 3, times the cube root of the remaining amount, which is z squared. Finally, we're going to leave as the cube root of x squared, because we cannot simplify that one any further. All right, the next piece here that we can simplify is this cube root of z to the 9th, and that becomes 2 times z cubed. And the remaining amount here needs to stay under the cube root, so it becomes z squared x squared. So our final simplification there is 2 times z to the third times the cube root of z squared x squared. All right. Our next one here, we're going to get the fourth root of 20 times the fourth root of x to the 8th times the fourth root of x squared. Now, there are no perfect fourth roots in 20, so we're just going to leave the fourth root of 20 there. However, we can simplify the fourth root of x to the 8th, and that's going to become x squared. So this is x squared, and then the fourth root of 20 and the fourth root of x squared just need to remain underneath that fourth root. So I'm going to push those back together, and our final simplification goes like this: x squared times the fourth root of 20x squared. All right, one final example here. We have the fourth root of 3 to the 6x to the 7th times the fourth root of 3 squared x squared. So we're going to combine these guys back. We have the fourth root of 3 to the 8th, because again we're going to add the powers on the 3, and then it'll be x to the 9th. All right, now we're going to take the fourth root of 3 to the 8th and separate that. Multiply that by the fourth root of x to the 8th times the fourth root of x to the first. So we took the power on 9, separated to 8 and 1, and the power on 8, or sorry, the power on 3, which is 8, stays because 8 is divisible by 4. So when we do this out, we're going to get 3 squared times x squared times the 4th root of x. So our final simplification here for this last one is going to be 9x squared times the 4th root of x.